Hello. In this video, we want to find the limit as x approaches 3 of the function f of x if f of x is equal to the piecewise defined function of 2x minus 1, given that x is not equal to 3, and 1 when x is equal to 3. Now, first of all, this last one here should just tell us that the coordinate will be 3, 1 there. So go right 3 up 1 and put a coordinate. So that's part of the function. The other part of the function is f of x here equaling 2x minus 1. This is just a line. And remember, lines are in the form of y equals mx plus b. So y equals 2x minus 1 means the slope is 2 and the b is negative 1. In other words, it crosses the y-axis at negative 1 and has a slope of 2. Now, the slope of 2 means we go up 2, right 1. Up 2, right 1, up 2, right 1. Now notice I'm going to do an open circle there because that's the x value of 3. Keep going, up 2, right 1. Fantastic. And down to left 1 does the same thing. Down to left 1, down to left 1. And then just connect everything with a trusty straight edge. Fantastic. So all of this combined is, in fact, the piecewise defined function. Now notice that f of 3 is equal to 1. Okay, that's important. But that's not the limit necessarily. In this case, notice the limit will be whatever it is as it's approaching here, and then here as well. It's one of the two. Well, actually, both of those. Now, because I have graphed this, we could go ahead and look at it this way. What's this y value here? Well, it's 1, 2, 3, 4, 5. So the limit as x approaches 3 of f of x should equal 5. And that is going to be the answer. But again, just to prove that this works using tables like this, let's go ahead and figure out some x values to use. So we want to have everything where x is not equal to the number 3. So let's go with numbers to the left of 3 and numbers to the right of 3. Let's start with, say, 2.9, and then 2.99, and then 2.999. Again, we never want to have the actual number 3 here, because it doesn't matter. Now let's do numbers to the right of 3. Say 3.1, 3.01, and 3.001. Awesome. Now notice what's happening here is that we're approaching 3 from both the left-hand side and the right-hand side. So let's go ahead and go to the calculator to see what these are actually going to be. I'll see you there. Okay, welcome to the calculator. Let's go ahead and go into y equals here, and we already are here. Okay, good. Let's go ahead and type this in. So for this piecewise defined function, the first definition was 2x minus 1. So 2x minus 1. And be careful, don't do the negative 1, just minus 1. Close parentheses. Open a new parentheses, and let's type in that condition. So let's go to second test. Then over here on conditions, notice that we need this to be x is not equal to, which is in this case is 0. So x is not equal to the number 3. Close parentheses. Then add on parentheses the definition of 1, close parentheses, and then open a new parentheses and type in the condition. So second math, conditions, x is equal to the number 3. Close, and then we're good. Now again, if we just graph this on the standard window, all we're going to see is the line itself, because 3, 5 is going to have a hole in the graph. And there will be a coordinate at 3, 1. It's kind of, you really can't see that on here. So you just have to, understand that that's what's happening here. Alrighty. So let's go ahead and go to vars right 1, enter, open a new parentheses, and type in these x values, starting out with 2.9. So when we type in the 2.9, that gives us 4.8. And let's do this again. Well, I prefer to do second enter here. 2.99 gives us 4.98. And then do that one more time. 2.999 will be 4.998. Notice that as x gets closer and closer to this number 3 here, what's this value approaching? It's approaching the number 5. If you want to see it one more time, do second enter and then throw on another 9, and notice it's getting another 9 there. You could even do it again if you want. And we're getting more and more 9s as this gets more and more 9s. Good. But real quick, notice though that when, there we go. When we type in 3 exactly, it gives us the number 1. Okay, that's the difference from typing in, say, 2x minus 1 instead of just the 2x minus 1, x not equal to 3 plus 1 when x is equal to 3. Alrighty, so go vars right 1 enter, enter, open a new parentheses, and let's do the other side, starting out with 3.1. So 3.1 gives us 5.2. Excellent. Do this again, making it 3.01, enter. We have 5.02. And then 3.001, enter, gives us 5.002. Awesome. So the more zeros we get, the more zeros we get here. So that gives us 5.0002. Next one would give us 5.000002 or something like that, and so on and so forth. So as x gets closer to 3 from the right-hand side, this is approaching 5. But again, remember when you are actually at 3 exactly, we get 1. So while it's approaching 5 from the left and it's approaching 5 from the right, the limit is 5. The function value is 1 down here, but that doesn't matter. For limits, the only thing we care about is what's the function doing as it approaches x from the left and then x from the right. And if those two function values are the same, that's what the limit is. So you have to be a little bit careful with that. Alrighty. Well, I think we should just go back to the notes, and I will see you there. Okay, welcome back to the notes. And in the notes, we see that as x approaches 3 from the left, it's approaching the number 5. And as x approaches 3 from the right, it's also approaching the number 5. Therefore, the limit as x approaches 3 of the function f of x is equal to 5. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.